notes over domain and a little bit of range will pop up in there. Our central question is, what are special function restrictions and how do they affect my domain? What are special function restrictions and how do they affect my domain? Where we're starting. Any questions so far? Okay, so we're going to dive in. Now, as you're going, I will tell you when to write. Got it? I will tell you when to write. Do not try to write everything down. One of my goals as a senior, maybe majority senior level teacher, is to teach you how to take notes so that when you go to college, you are not lost and confused. Okay? A good way to learn how to take notes is through Cornell Notes. Because it's think about the space, you have to be smart about what you're writing. Are you writing important things or are you just writing things because you're not paying attention, you're just writing to stay awake? Okay? That's what we're going to focus on. So, do not write. Domain basics. So things that you should already know about domain and range. I mean, not domain and range, but just about domain in our class. We reviewed how to write the domain of a set of coordinate points from a table and a mapping, right? Hopefully you're all very comfortable with that because that was like the first 2 questions on your quiz. Writing the domain given a table and a coordinate points and a mapping. So when you do that, you list your x values in order from least to greatest and call it a day, right? That's just very beginning, 8th grade, pre-algebra, domain and range, okay? Next, in Algebra 1, you spent an entire year learning about linear functions, pretty much. Like, what does a linear function look like? What can it do? How do you transform it? All that. And at the end of it, you should have learned and taken away that the domain of every single linear function is all real numbers. If my highest exponent is 1, that's a linear function. So its parent function is f of x equals x. If I had a function in slope-intercept form, so that whole y equals mx plus b, that's a linear function, right? And so the domain would be all real numbers, okay? And then you focus on the fact that domain of all quadratic functions make a special U-shape. What is that U-shape called? A parabola. It makes a parabola, right? And the domain of that parabola is all real numbers. It says on the board. I was hoping we all said in unison since it was written. Okay? It's all real numbers. That's because the graph goes forever to the right and forever to the left, right? It doesn't stop growing. You just see a limited on your calculator screen, but it doesn't stop. Does this sound familiar? Any questions about the basics? Okay, good. So, next we're going to go over on page 5. That's why there was glue out, so hopefully you picked up the glue. On page 5, we should have set up yesterday our thingy-mabopper. I can't even talk. Inequality versus interval notation handout. Did we do that? Yeah. Yes. Look how prepared we are, guys. Look at our preparedness. Okay? We're going to write some stuff around it. Okay? So in the spaces around it, we're going to highlight some stuff. If you look at the blue right here, this is our set builder. Okay? Set builder does not change the inequality. It just dresses it up. Okay? It makes it fancy and formal. So our set builder stands for this x right here means that I'm defining x, right? If I was defining y instead of an x, I would put a y. Okay? This little guy right here, this line, that line, it stands for such that. So you're saying x such that, I'm moving something too much. You're saying x such that, that line, x is greater than 5, close your brace. That is all set builder does. It dresses up your inequality. Okay? So if we do it again, let's take this guy right here. I want to put this in set builder notation. So all I'm going to do is write a brace, x such that x is greater than 1 but less than 5, close brace. Set builder. Boom.
That's all we doing on this?
In 5 seconds. That was so hard, right?
Yeah.
I'm so sorry that I forced you to go through that. I'm not going to make you go through and transform all. I feel like if I did one and we did one together, you get the idea of coming into set builder, right? Does anyone need to see us do it 10 times?
Yeah.
Really? Then close your eyes and imagine it. We're not doing it 10 times. But that's what you're doing for set builder. Comfortable? All right, cool. So we're going to describe some of our symbols. If I have an open circle or a hole in my graph, that means that this right here, I use strictly less than and strictly greater than. So that point is not included. And because it's not included, when I write my end behavior, I use parentheses because it's not included. Okay? If I have a closed circle, that means I am less than or equal to or greater than or equal to, and it is included. And I use the bracket. So do you guys remember how in our word problem when we were looking at that table, the values that had the hole we skipped, right? So we would jump over, oh, there's a hole, can't use it. I went to the one above it, right? That's because it was not included. Okay? This is how I think of it. This is our way of learning in algebra is inequality, right? And then in algebra 2, you learn interval. I call this lazy man. Interval is lazy man writing. And then fancy is our set builder. And set builder is where it gets fancier. Okay? What I like about inequality is that it tells me which direction my domain is going. If you look right here, notice how my greater than is pointing to the right. So if my greater than is pointing, I'm trying to like erase that. It's not being okay. Come back. Come back. You're thinking, I feel it. It didn't work. Go went away. Okay. So we'll practice it again. X.
What is that right there that you just drew? That little squiggly S.
My brace?
Oh.
That's the best I can do. Okay? Please don't judge it.
I'm sorry.
I feel like they're pretty good. I've come a really far ways with my braces. So they used to be really questionable. Okay, that one is. Eraser is too large. Figured that out real quick. All right. That was pretty good. That was pretty good, guys.
Yeah, I like them.
Yeah. I do too. I'm proud of it. So if you look at your arrows, it tells you which way your domain is going. So if it's greater than, then my domain is going to the right. If it's less than, then my domain is going to the left. The arrows help you. And they are pretty smart arrows. They're like, if you follow them, you won't mess up. Okay? The arrows also tell you which side there's tape on me. Which side your infinity goes. If it's going to the right, then I know that my infinity is the value on the right. If it's going to the left, then I know my infinity is the value on the left. And what's the value of infinity on the left? Negative. And what's the value of infinity on the right?
Positive.
Positive. Arrows are wonderful. Just follow them. They lead you to exits. They lead you to treasure maps. Look, treasure maps have arrows on them and they lead you to treasure. Yeah, that's the word it goes in. All right. Any questions about inequality and interval notation and how they lead to set builder? Are we comfortable with this? Or do y'all need to see me do it again?
What about the
set builder
or
again?
What about the or down here?
So or we're going to dive a little deeper into through once we get to rationals. But or just means that you have a split domain. So it's going to go one way, go another way, and they're not connected. So we have to use the word or shorthand, the U for union. They unite here. The union. But don't worry, we're going to dive deeper into this once we get to rationals. We will be using this page 5 all year long for the most part. So we'll be referencing back to page 5 all year long. Got it?
Yeah.
All right. Don't look. Please close your eyes in a second because I have to erase the board because it has all the writing on it and I just remembered I didn't erase it. So after this page, close your eyes. Domain restrictions is what we're going to talk about. So domain restrictions, we're going to go over square root functions, rational functions, and real world. Okay? Basically, there are functions that can equal certain things. And so it creates a natural restriction on your domain. And that's when the inequalities come to play. I told you don't look.
Whoops.
Take a photo.
Somebody take a picture.
Why?
Airdrop it.
It won't go to the big eraser. Are you freaking kidding me?
Take a picture. I'm finna airdrop it too.
Won't go to the big one. You see nothing. You did not.
Airdrop it too.
Yeah, got it.
Alright, here we go. So we're going to start with the square root function. Write this down. Square root function. What does the square root function look like? F of x equals the square root of x. That is your square root function, correct? Yeah. So, square root is f of x equals square root of x. That's our parent function, right? Under the square root function, you cannot have a negative. Can someone tell me why you can't have a negative underneath the square root function?
We don't work.
Okay, but why is there no square root of a negative?
Because it'll turn back to a positive.
Because what? It's going to always equal to a positive, right? If you take a negative and multiply it by itself, which is another negative, it's going to make a positive. So it's impossible to make a negative underneath the square root. So if you have a negative underneath the square root, then it's not a function. It doesn't exist. Okay? So, with all of that being said, when we are trying to find the domain, we have to solve the inequality x is greater than or equal to 0. That is what you have to do in order to find the domain of that function. Alright? So please note that x is greater than or equal to 0 is the domain of the parent function. Because what kind of numbers are greater than 0? All positives. And they're all good to go under there, right? So that's okay to have. But if I go less than 0, then that's all of my negatives. And we can't have them. So the domain here of this parent function is x is greater than or equal to 0. This is my inequality domain. Agreed? If I want to take my inequality and turn it into a set builder, I'm going to write braces x such that x is greater than or equal to 0, close braces. Mathematical sentence written. Does that sound doable? If I asked you for interval notation means that I'm using brackets or parentheses, right? And so my interval notation is where do I start on the left and where do I end on the right? So if I am x is greater than or equal to 0, where am I starting on the right?
Infinity.
No, I'm ending on the right. I'm sorry, that's right. I end at positive infinity, and where do I start on the left?
0.
0, right? Because it says x is greater than or equal to 0. So 0 is my starting, and infinity is my ending. So those are the 3 ways to write the domain of the square root of x. All right, we're going to practice. So there's 2 steps. So step 1 is to set up. When you set up, it's going to always be what's under the square root is greater than or equal to 0. So whatever is under the square root is greater than or equal to...
You can't write that. That's what you said.
Huh?
You can't write that.
Yeah, we're going to do the example. Unless you don't want an example. If you don't want it, I can't force you to write it. But I strongly suggest it. Alright, so step 1 is done. Step 2 is solve for x. So I'm going to have 4 minus 3x is greater than or equal to 0, and I'm going to solve for x. So my goal is to get my x by itself. Okay? Huh? So before I can do that, what's my first line of defense to the x? The 4, right? The 4 is my first line of defense. So think about if you are a burglar and you're trying to rob a bank. Is it going to be easy, or is it going to have to be things you have to get through to get closer to the vault? Things you got to get through to get closer to the vault, right? So my first line of defense here is the 4, so I have to knock out the 4. So how am I going to knock out this 4?
Subtract.
I'm going to subtract it. And what I did on one side, I did to the
Other.
and I'm left with negative 3x is greater than or equal to negative 4. And then I'm like, oh, I still don't have the money. So what is my final line of defense?
Negative 3.
I'm going to do what with the negative 3? Divide. Because this is multiplication, right? This is negative 3 times x. And the opposite of multiplication is division. Can someone tell me what happens when you divide by a negative in an inequality? You have to flip the sign. When you divide an inequality by a negative, you have to flip your inequality. And then you continue to divide. When you divide or multiply an inequality by a negative, you have to flip the switch. Flip the switch. Flip the switch. Flip your signs. Don't tell me that. That hurt my feelings. So that eliminates, and then I'm left with x is less than or equal to a negative divided by a negative is a positive 4/3. Fractions are okay answers, y'all. They are real live answers. So this is my inequality. If I wanted to transform my inequality to set builder, I would take my brace, my x, such that x is less than or equal to 4/3. Close my brace.
If you want to change it, so what?
Set builder. I did switch.
Do you gotta do that in the session?
So on the problem, it'll ask you, it'll tell you which way it wants your domain written. If it says write in set builder, boom. If it says in, I'm about to finish it, we're going to be our starting point. Last way, yes, Alex.
No, you can.
Okay, our last one is interval. I need to write this interval notation. So if I'm going to the left forever, what's over there?
Infinity.
What kind of infinity?
Negative.
Negative infinity. So it'll be negative infinity, comma, 4/3 bracket. And those are my 3 possible ways my answer can look. Inequality, set builder, and what's the face C? Interval. So when we come in tomorrow, we're going to pick up here. It would be a negative because you have 2 negatives. And a negative divided by a negative is there. Positive. All right? Bye, y'all. Have a good day.